Hi all. We're going to continue to look at Newton's second law, right? And one of the quantities that Newton had defined was the measure of momentum. He defined the measure of the measure of motion. He defined the measure of motion as momentum, mv, as we know it, right? So similarly, we look at what is the measure of motion in rotational motion. It has to be the counterpart of momentum, which is used in translational motion, and the counterpart of momentum is angular momentum, right? So let's just draw the parallel and understand what angular momentum could be, right? We saw momentum was given by mass into velocity. Similarly, angular momentum, which I'm going to represent by L, which is a vector, is equal to mass. The mass of the inertia of rotational motion is moment of inertia into omega, right? And we know that the science was very clear when we used angular momentum. When we used momentum, the sign was in the direction of the direction of velocity. It's a vector quantity. Angular momentum is also a vector quantity, and it is given by the direction of omega, right? So this is how we measure angular momentum, right, in rotational motion. And we complete Newton's second law. If you remember, Newton stated that, yes, the force was the rate of change of momentum. Similarly, when we look at and draw the same parallel in angular motion, torque is the rate, or angular momentum, torque is the rate of change of angular momentum. Or we can represent Newton's second law in a different direction. The torque is equal to the rate of change of angular momentum, right? So we looked at this new quantity, which is angular momentum, and it's a very important quantity which we will revisit later. Thank you.